Hello everyone and welcome back to another video. And it is almost 4 in the morning, and yes, I am pretty tired, but I'm also really excited right now because of two things that worked out really nicely. Now, only one of those things is like in the title of this video because the other thing isn't really that interesting, but I still like that it worked out. So the main thing is again about the GTX 460, which is now the CMD Edition V3. The last video was about a V2. This is now V3. And like visually, nothing really has changed, except when you look at this part, which I'm gonna have to activate the light on the camera. You can kind of see these MOSFETs do look different. Like, these have light writings on them, and this one is different writings on them from these two. That's because all of those MOSFETs, every single one except this one, have been desoldered with my hot air station. And this time I did record it. Not everything of it, but I recorded the process of me removing the MOSFETs. I would like to say I have one of me putting them back on, or like putting the new ones back on, which is what I did. It should be on screen right now. So yeah. So let's first talk about what I wanted to achieve with this. So the low side MOSFETs, the 6 ones with the lighter writing on them. So these 6 here, I set out to replace these ones because the low side FETs that the card comes with, which are actually right here, except this one is another one. Yeah, these are, I mean, yeah, they work when you have the card stock, but like, I want to overclock it. And for overclocking on Fermi, it's a pretty good idea to increase your V-core. And if I increase the V-core on this VRM with these MOSFETs, which is uncooled, even though there's 2 screw holes right here, the VRM won't take that. Like, I do not trust the VRM to take that much voltage. At some point, it's going to blow up. I haven't managed to do that, sadly, or not sadly, depends on how you see it. So yeah, I mean, the main idea is still to e-power this thing, because like this is a test card, just like the other one left to me, which is the other thing I'm going to talk about. Both of these are like my test cards, and this one, I wanted to test the e-power on this once I make it. Still haven't done any progress on that because, well, I've done these 2 things. So before I e-power it, I wanted to test, can I reliably hot air new MOSFETs onto a card? Because again, this card right here had this high side here blow up. I replaced it, but the card doesn't, it can't handle as much power as before, which is, well, that high side that I put on there is an older model that's not as good. And the VRM is like not that great from the beginning. So I decided, okay, I'm gonna get MOSFETs and like replace this VRM, like replace the MOSFETs on this VRM to make it better. And well, that's exactly what I practiced for right here. Like I'm going to use the same MOSFETs. These are the ones that I put on from Vishay Semiconductor. These are SI R158DPs. These are 60 amps continuous drain current at a low temperature and like 40-ish at a higher temperature, which these are probably running at. These are 1.8 milliohms RDS on. So these are pretty good, nice MOSFETs. They are also pretty expensive, with almost $1 a piece. These are not the most expensive MOSFETs, but they're like pretty, like I paid 20 bucks for 37, I think, of these, and I've already used 6 of them. So yeah. And that's kind of what I tried to do. So I desoldered these old MOSFETs, put the new ones on, but sadly I kinda got some problems. So you're going to see this fan connector looks kinda scorched, because it is, and these 3 spots did have capacitors in them. Actually, they are right over here. And you see one of them kinda doesn't look so happy. And this one is also bulging a bit. Yeah, so like I used my piece of aluminum foil or aluminium foil, depending on where you live. I put it over the capacitors to shield them from the heat, but apparently that wasn't enough. I do have a recording of it happening. You can hear a pop. You can't really see it because it was under the protection, but one of those capacitors blew up. Another one started bulging, and so I just removed all of them because I knew I would just blow all of them up in the end. So yeah, I'm missing 3 of the 4 16-volt capacitors now. I guess I'm gonna try to put some on the back, because I do have plenty of these right here, 16-volt ones, for 70 microfarads, like about twice the capacitance of these, which like, yeah, kind of correlates with the size. So I'm gonna look for a way to put these on, but actually, like, I ran benchmarks already and the card hasn't degraded in performance, so technically it might impact future revisions of the card, but like right now it's actually not doing anything, but like I would still like to put those back on. So yeah, I put these MOSFETs on, the new ones, and well, it cost me 3 capacitors and this fan connector that I don't use. But then I was finished. Like, I checked for shorts, the card checked out, I put it in the system, and it booted up. And I thought, okay, great. Let's run a benchmark, because this VRM should now be substantially upgraded, because these MOSFETs are like pretty good. Not the best, but pretty good. And these are like, yeah, it runs stock, it's gonna blow up if you do anything else. So yeah, I tried to run a benchmark, and after literally like 1 or 2 seconds, I hit overcurrent protection. And I was like, oh, yeah, I might have messed up the soldering on one of the low sides and blown it up, but no, that's not what happened. What I did worked out completely. What actually happened is that one of the high sides blew up. I didn't do anything to the high sides here. I messed with the low sides. The only thing that could have happened is, like, because of the heat from the hot air, I might have destroyed one of the high side FETs, but like it worked briefly, and like whatever, a high side died. And I spent a lot of time searching for shorts on the card. And for some reason, I assumed the 12 volts power planes from the 2 6-pins are like shared, and they're not, which is why I never found the short in the beginning. So I always check this connector, but actually this connector, which is connected to the 2 upper phases, that one has to short. This one was fine. This is powering the lower phase. And then PCIe is powering memory. So that's like your power distribution. And yeah, so this one had 12 volt, almost shorted to ground, because it was shorted to V-core, which is like 1 ohm to ground. So it appeared as a short to ground, whereas actually it was a short from 12 volts to V-core, which is a dead high side. So I knew that either this or this MOSFET are dead, and what I've said from the beginning, you're going to know that this MOSFET is the one that died. I actually ended up desoldering both of the ones, because, well, both of these phases are on that connector, and like there was no visual damage, so I just had to guess, and I guessed badly. So I removed both of them, and the one that I removed last ended up being the dead one, which is this one. Actually, you can see I've marked it by breaking it in half, so I never use it again because it's dead. And yeah, that's why there's a 4921N here instead of the MDU 2656s. Yeah, because I don't have the MDU chips on hand, and the 4921N is like, I think it's actually better. Like this one is the high set that the reference cards from NVIDIA use, I think. And this is a reference PCB except for the MOSFETs. Zotac, for whatever reason, chose to use different MOSFETs, which there's no full datasheet for them, but I know someone who like knows some details about them, and from what they've told me, these are pretty bad. Like the MDU FETs are like same or worse as the reference ones. So this 4921N here is completely fine. And that was the fix. The card now works. It works completely. It was kind of a longer project than expected. I was thinking just, okay, MOSFETs out, MOSFETs in, maybe try to not blow up caps, which didn't work out. Well, yeah, finish. So I ended up also replacing a high side, and now the card works again. It runs benchmarks like it did before. It overclocks. Like there's no difference in how it performs or overclocks now, because like I just upgraded the VRM. It can run a higher voltage now, and it's more efficient because the IDS-on is lower on these. So I've made the card more efficient and capable of running more power through the VRM, so it won't blow up as soon now, which is a good thing. So yeah, there's no difference to the actual performance, but now I have improved the overclocking headroom, because like the main things you run against for Fermi is like thermals and VRMs, and on a reference card like this it's gonna be VRMs, because like I still have this custom heatsink right here, which is pretty good. Like this is already a pretty good performing heatsink if you put like a 140mm fan on it, and the card is delidded, so thermal wise the card is doing pretty good. It was just the VRM that was the big thing that was holding it back, and now I removed that problem. So now I could like do a volt mod on this PWM controller right here, and 1.35 volts maybe. Like I've had 2 or like 3 cards with shorts from VCore to from 12 volts to VCore in my test bench, and always the power supply tripped over current protection fast enough so that no damage was ever done. So I'm pretty confident that like this VRM is gonna take a lot more, and if I manage to blow it up, the power supply will take care of me. But this should be capable of a lot more than before now, which is yeah, exactly what I wanted. And like this is looking pretty nicely. Like this one is slightly misaligned, but like this is looking pretty good, I think. Like if you look closely, yeah, you kind of see like there's a bit of solder, like not solder, there's a bit of flux around, and like these are slightly misaligned, and obviously they're mismatching. Like there's magnet chip, there's Vishay, and then there's an on semiconductor MOSFET. So obviously someone messed with this card, because usually you have MOSFETs from just one manufacturer. So yeah, that's kind of the main thing I wanted to talk about. Like the CMD Edition V3, like there's no performance difference, but like just the PCB got a lot better. And yeah, like a V4 will probably have a volt mod for a core, will maybe have some more capacitors, because I did also get new capacitors, like here. So I've got a couple 820 microfarad and 1000 microfarad ones. Both of these are 2.5 volts. These have 5 volts ESR. These have 7 milliohms ESR. So yeah, like these have much higher capacitance than my older caps. These have better voltage rating than my old capacitors, and the RDS-on is not RDS-on. The ESR is better or same. So yeah, these are doing quite nicely. These came in the same package that I got the MOSFETs from, and in that package there were also some 8 milliohm shunt resistors. So yes, shunt modding is now possible. And yeah, So this one got new MOSFETs. So let's talk about the other thing that you were able to see on your left the entire time. So speaking of capacitors, more capacitors. So these 6 1000 microfarad ones, these are new. The other ones I already had before. You've probably seen these in the other videos. So yeah, like this is the Zotac GTX 580 reference board, except also it's running these different MOSFETs for whatever reason. I don't know why Zotac did that, but it is using different MOSFETs. But like I'm not pushing ridiculous voltages into the core. Like this is also a test card. And yeah, I'm testing cap mods on this at the moment. Like specifically, I'm testing the impact on a card that really has a pretty... It's a reference card, the VRM is not great. So I'm testing the impact on a weak VRM, which it should have the most impact here. And yes, it did make a difference. And like, yeah, like this is not a really special card. It's a reference GTX 580. I got it for 15 bucks because it was dead. I heat gunned it back to life. And now I abuse it for testing. So the thing I was testing just like what the cap mod does, and I was testing to make them look better, which I think again I achieved. Like these caps before, the smaller ones already look pretty well, and now the big ones, well, these are not as nicely aligned because they're just way too big, and they come with the legs pre-trimmed. Like these come with very, very short legs, so I couldn't place them anywhere else, like in any other form. But I think this still looks pretty well. The card now is a free slot, which isn't really a problem. I have enough space on the test bench. And for whatever reason, this card doesn't work with the PCI Express riser. I usually have a riser, so the card can pull in free fresh air, because I don't have a side panel. Because if it's sitting in normal without the riser, it's just like pulling air from... Well, yeah, the side panel is still open, but like from within the case and not really from the outside air. Yeah, for whatever reason, this card just doesn't work with that riser. Like it won't be detected for whatever reason, but like it works without it. So, yeah, and so this card now has an additional 6,000 microfarads. Which these before the card had an extra 2,800 microfarads. Now it's getting 6,000, so quite a lot. And also these are 2.5 volts. The other ones are 4 volts. The other ones are 7 milliohms. Like actually, these are also 7 milliohms. The smaller ones, the new ones that I got, are 5. And then all of these caps, these are on the memory. These are not affecting the core. And yeah. So I got about 20 megahertz extra on the core from this, which 20 megahertz, that's pretty nice. The only thing about it is like it's not a definitive 20 megahertz because I didn't really bother to fully stress test it before. Like I had this, it now does like 915 megahertz or whatever in a longer benchmark like Heaven. I got it to pass Firestrike at 940, which is a lot. But like Heaven, it runs at like 920, 925, which is where that 20 comes from. Because I never knew like what it does in a short benchmark before, because again, I didn't bother with stress testing it all the way. Like it's a test card, which like it's not a scientific test card. It's just a I want to try something card. So I don't have really documented anything. But yeah, like I now have more and better capacitors. I've got some more practice soldering with them, and I think again it looks pretty great. Like this card is the best looking mod I have done to date. Like none of them other cards look as great as this one. And I've done a lot, like these are a lot capacitors. I think these are the most capacitors I've ever soldered to a card. And to have it then also be the best looking one is pretty nice. But yeah, like there's nothing really anything more to talk about this, like, yeah, it's got more caps, it's running slightly faster now, which is why the main focus of the video was the MOSFET switchering of the 460, which I'm probably gonna mess with this a little more, so there's probably coming a CMD Edition V4 until I finally get around to doing the E-Power. Then the MOSFETs are like, yeah, then they don't matter anymore, so I can reuse them on something else. But yeah, we are at 20 minutes already again, which is where my videos usually end up. So yeah, I've got no benchmarks for this, so this is going straight to the outro. So yeah, thank you for watching, hope you enjoyed, and until we see each other next time, goodbye.